It's a cold night in Cambridge, Massachusetts. The year is 1908. In a dimly lit room at Harvard College Observatory, a young woman sits at a wooden desk, hunched over glass photographic plates. Each one is the size of a book, covered in thousands of tiny black dots, stars, captured on film. Her name is Henrietta Swan Leavitt. She's deaf in one ear. She earns 30 cents an hour. And tonight, as she measures the brightness of a star that flickers in a distant galaxy, she's about to unlock the ruler of the cosmos. She doesn't know it yet. Neither does anyone else. Outside, the world moves on. Automobiles rattle down cobblestone streets. Electric lights glow in windows. The 20th century is accelerating into modernity. But here, in this quiet room, time moves differently. Here, Henrietta is touching light that left its source thousands of years ago. Light that crossed the void, while empires rose and fell, while humans learned to write, to build, to wonder. This moment, quiet, methodical, almost invisible, will change everything. For as long as humans have looked up, we've asked the same question. How big is the universe? The stars seemed close, beautiful, fixed in place like jewels on velvet. Ancient astronomers thought they might be holes in the celestial sphere, letting divine light shine through. Later thinkers imagined them as distant suns, perhaps with their own worlds orbiting in the darkness. But were they? How far away were they really? Were they all part of our galaxy, or were there others, island universes drifting in the void? No one knew, and the question mattered more than ever, because by the early 1900s, astronomy was becoming a science of precision. Telescopes were growing larger, photography was replacing hand-drawn sketches, data was accumulating. But without knowing distances, it was all just beautiful guesswork. To measure distance in space, you need something reliable, a cosmic yardstick, something that tells you, with certainty, how far away a light truly is, something constant, predictable, universal. And in 1908, no such thing existed. The universe, for all our instruments and theories, remained unmeasurable. We were like sailors trying to navigate an ocean without knowing how far the horizon extended. At the turn of the century, astronomy was changing faster than ever before, but some assumptions remained unquestioned. Most astronomers believed the Milky Way was all there was. The universe, they thought, was a single galaxy. Vast, certainly, but finite. Everything else, the glowing spiral clouds called nebulae that telescopes revealed scattered across the night sky, were just gas and dust nearby, part of our neighborhood. Cosmic weather patterns in our own backyard. It made sense. The numbers supported it, or at least, they didn't contradict it. To find out if that was true, you'd need to measure distances. But stars don't come with labels. A dim star could be close and faint, or far away and brilliant. A bright star could be nearby and small, or distant and enormous. Without knowing which, you couldn't map anything. You couldn't answer the most basic question: where are we? Scientists tried various methods. Parallax, measuring how a star's position shifts as Earth orbits the Sun, worked for nearby stars. But beyond a few thousand light years, the shifts became too small to detect. It was an impossible puzzle, and so the universe stayed small, contained, manageable, comfortable, until Henrietta Leavitt started noticing patterns in the data. Leavitt wasn't allowed to theorize. At Harvard, women weren't hired as astronomers. They were computers, human calculators, who sorted data, measured star positions, and catalogued brightness. They worked in a separate room, away from the men who published papers and received recognition. The director, Edwin, had hired them partly out of progressivism, partly out of economy. Women were paid less than men, much less. Henrietta earned 30 cents an hour. A male astronomer might earn $3. It was repetitive work, tedious. Day after day, plate after plate, measuring the same stars over and over, tracking changes in brightness, recording numbers in ledgers. But Leavitt was brilliant, and she was patient, and patience, in science, is a kind of superpower. She was assigned to study a type of star called a Cepheid variable. These stars pulsed, growing bright, then dim, then bright again, like a cosmic heartbeat. Some pulsed quickly, flashing every few days. Others took weeks to complete a cycle. Astronomers had noticed them before, but they were considered curiosities, interesting, but not particularly useful. Leavitt studied thousands of them. She focused on Cepheids in the Magellanic Clouds, two fuzzy patches of light, visible from the southern hemisphere. And because all the stars in those clouds were roughly the same distance from Earth, she could compare them fairly, and that's when she noticed something extraordinary. The brighter a Cepheid was, the slower it pulsed. She recorded it carefully, checked it again, then again. The pattern held across every star she measured. It wasn't random, it was a relationship, a law of nature. And then the full implication hit her. If you knew how fast a Cepheid pulsed, you knew its true brightness, its absolute luminosity. And if you knew its true brightness, and compared it to how bright it looked from Earth, you could calculate exactly how far away it was. It was breathtakingly simple, elegant. A cosmic lighthouse, a standard candle that burned the same brightness across the universe, allowing you to measure any distance. In 1912, she published her findings in a short paper in the Harvard Observatory Circular. No fanfare, no press conference. Just 25 pages of data, measurements, and one quiet conclusion that would reshape human knowledge. She had found the ruler of the universe, and she'd done it by simply paying attention. Today, astronomers still use Cepheid variables to measure distance. The Hubble Space Telescope, named after the man who built on Leavitt's work, has photographed them in galaxies millions of light years away, refining our cosmic map with precision she could never have imagined. We've used her method to measure the age of the universe, 13.8 billion years old. We've weighed galaxies, tracked the mysterious force called dark energy that's pulling the cosmos apart, watched the universe stretch and evolve in real time. Her work is the foundation beneath every discovery about the scale and fate of existence. When scientists talk about cosmic distances, when they measure how fast the universe is expanding, when they peer back toward the beginning of time itself, they're standing on shoulders that were never properly acknowledged. And yet, for most of her life, she was invisible. A woman in a room full of glass and silence, doing work others called clerical. Work that required genius, but was classified as assistance. History forgot her, but the stars didn't. There's something humbling about Henrietta Leavitt's story, something that cuts through the romance of scientific genius and reminds us what discovery actually looks like. She wasn't famous. She didn't have access to the best tools or the loudest platform. She couldn't even use the telescope. That privilege was reserved for men. She was paid almost nothing, denied recognition, working in the margins of a field that barely acknowledged her existence. And yet, she saw something no one else did. Because discovery doesn't always come from the center. Sometimes, it comes from the edges. From the people who are patient enough to look closely, curious enough to notice patterns in data everyone else considered routine, brave enough to trust what they see, even when the world isn't watching. Leavitt gave us the universe. Not by shouting, but by measuring. Not by demanding attention, but by doing the work, night after night, plate after plate, until the pattern emerged. And maybe that's the real legacy. That the most important truths are often found quietly, by someone, somewhere, who simply refused to stop looking, who believed that every measurement mattered, that every star had a story to tell. The stars are still out there, still pulsing, still waiting to be understood. And somewhere, in that rhythm, in the heartbeat of distant suns that Henrietta Leavitt first learned to read, is the echo of a woman who taught us how to measure infinity, who showed us that the universe was bigger than we ever imagined, and who did it all from a desk in Cambridge, one star at a time.